Hello everyone, in this video we are going to discuss how OpenCL complete stack works. Let's get started.
Imagine your computer as a company with two different types of employee. First, CPU, the senior engineer capable of doing one or two tasks at a time but will execute with precision and strategy. If you have seen Despicable Me movie, think of CPU as a group who is carefully plan and execute his strategy. Second type of employee in your company of a computer is GPU. Say hello to GPU. Think of it like an intern. They are less powerful but excel at a repetitive task. Data parallel work best when same task is repeated across large dataset. Imagine you have a room full of minions, incredible for when task is given to them. Till now we have get little bit idea about what is GPU and CPU. But now the question arises, how do they communicate? In company terminology, if you see, the senior engineer and interns communicate through project manager, and they have their shared resources where they put their code and everything such as Git and GitHub. Similarly, OpenCL in GPU and CPU act as a project manager who organize the workflow, allocated right tasks to them, build shared workspace where all can communicate. The shared workspace in OpenCL is called a context. Think of it as a meeting room where senior engineer and intern communicate in presence of project manager to discuss what next to do. Context is the place where data is shared, kernel functions are loaded, execution across devices are happening. Key component inside the context are a first program. Think of it as a manual in which it is written what GPU and CPU will do. This manual or program consists of one or more jobs called kernel. Here is an example of simple multiplication of two array and storing another array. This is a kernel code. This we write in a program. This get code compiled into a kernel. What is kernel? Think of kernel is a mini job description for GPU interns. It specifies what each thread, that is company intern, will do. How this will work? It will take an element ID from array A and array B, multiply them and store in C. Here R1, R2 and R3 are the value what it is taking. R1 and R2 are input and R3 is the output. You can see from the code. When the kernel is communicating with each other, we need to have a place where CPU and GPU can communicate. This is called as memory buffer or memory object. These are the chunks of memory shared between CPU and GPU, where GPU puts data input, GPU reads and write data during kernel execution. It can be form of image or in the form of buffer. This is called as data and argument we need. So third step is kernel execution. So for that we require a command queue. To-do list for a GPU. Command queue is nothing but a to-do list for a GPU, such as what to execute in what order, in order, out order, or in what sense. Finally, this is executed for getting a job. The GPU start executing the kernel, thousands of thread chunks of work each. Final results are sent back to the CPU for using and display.